Geometry lesson 12.7, we're going to look at the AA and the SAS similarity theorems. So if you think back to when we did congruence theorems, AA was not a viable theorem to use to prove that they're congruent because we've now seen, first of all, if two angles are the same in triangles, the third angle is automatically the same. But when you enlarge a triangle or shrink a triangle, the angles stay the same. So you can have matching angles and they're not congruent, which is what we studied before. But if we have three equal angles and all you need is two to prove there's three, then you do have similar triangles, okay? And SAS will also work. So the big idea says the conditions that guarantee similar triangles are analogous to the conditions that guarantee congruent triangles. That just means the same. AA being the only difference there. So the basic understanding of these we've already studied. The AA similarity theorem, if two angles of one triangle are congruent to two angles of another, first of all, we automatically know the third one is congruent as well. But the two triangles are similar, not congruent, similar. In SAS, if in two triangles the ratios of two pairs of corresponding sides are equal, then the included angles are congruent, then the triangles are similar. So notice that this is not saying that two sides are equal. Two sides are in congruent ratios. So we set up the scale factor and we make sure that they are creating the same ratio between the triangles. If you have two sides, because we need three sides if you're just using sides, three sides all in the same ratio. But if you have two sides and an angle that's between them, it must be side angle side, not side side angle, then you can prove that they are similar. And then we're not writing proofs here, don't get worried. We are just going to kind of explain why things are or are not similar. So example number one. Well, we have these two triangles and they tell you that WT and VU are intersecting at X. We have right angles here. Name the theorem that proves that these pair of triangles are similar and then provide a similarity statement. So first of all, right now, because I have these two 90-degree angles, let's go ahead and write that out. Angle U is congruent to angle V because they are 90 degrees. I also know that this angle equals this angle. So let's name that. We're kind of writing a proof here, but not really. So angle TXU is congruent to angle WXV, and because they are vertical angles. And so right there, we already know that those are similar because I have two angles. The third angle would be matching as well. W is going to equal T. That's the third angle theorem, right? If two angles match, the third one automatically matches. So I know these two triangles are similar. We're going to go ahead and write a similarity statement. This is by angle theorem. And so we have to make sure when we set up our similarity statement that our vertices are in the right order. So the first one you can name however you want. I'm going to call it TXU. Make sure you don't write congruent. They're not necessarily congruent, but they are similar. And so T is going to go ahead and match W, so I have to put that first. X is that equal angle at the middle. Okay, so that has to go there. And then the 90s match, so U is going to match V. This is your similarity statement. Triangle TXU is similar to WXV. You can write it differently, but you need to make sure that the vertices that are equal to each other are matched up correctly in your statement. Okay, example number two, very similar. I have parallel lines. So think back when we were doing proofs a lot. What we know from parallel lines, we have alternate interiors, we have corresponding angles. Name the theorem that proves that two pairs of triangles in this picture are similar and then provide a similarity statement. So the triangles we're looking at here is this smaller one, PST, and this bigger one, PQR. They both share angle P, right? Angle P is in both triangles if you separated them. If you redrew this triangle PST and the bigger triangle PQR, they both have that one. So that one's going to match. And just to remind you what that was called, that was the reflexive property when you use the same angle in both of them. And then we only need one more angle to prove that these are similar. And so you could use S and Q over here or T and R. they are both going to be corresponding angles. So I'm just going to go ahead and use this one. These angles are going to be equal because I have parallel lines being cut by this line. They're in the same exact position. So therefore, those are going to be corresponding angles. So we will write that out. We can call this angle Q. It's going to be congruent. We can't call this S because there's more than one angle there, so we do need to name it fully. That's going to be PST, and that's because they are corresponding. All right, so this is your angle-angle theorem. Again, not writing it out super formal, but it is a little bit like a proof. We're proving that these are similar because I have two equal angles. Obviously, I have three equal, but you only need two for this theorem. And so let's go ahead and write our similarity statement. So I'm going to start with PST, and it is similar to, and this is just going to follow the same way around. P matches P, S matches Q, and R. So PST is similar to PQR. All right, to the back. So we're going to have these problems. You're going to see these a lot. They love these ones with the shadows being cast because they do create similar triangles. We've kind of talked about them using Pythagorean theorem possibly. That's one way to solve some of these. But in this case, we're going to relate this to similar triangles. So you can see the meter stick and the cactus are both casting a shadow from the sun. And what we're going to do is we're going to make triangles, which we've kind of done before. But what we need to know is that this creates two similar triangles. It does. Now, the reason is because this is creating parallel lines here and the ground. So I've got this one and I've got this one. The angle of the sun, because it's coming from so far away, the rays are said to be parallel to each other, and they are pretty much parallel to each other. It's close enough that you can actually use this in real life for measurements. And because the ground forms a line here that's cutting those parallel lines, I automatically know that these angles are equal to each other. And so I have the 90-degree angles and I have these angles here, assuming that both of these are straight up and down. So I have enough here to prove that these triangles are congruent. I'm sorry, not congruent, similar. And if they're similar, I can go ahead and match up corresponding sides. They are going to be in proportion. So let's see what that means. So first of all, it's a meter stick, which means it's 1 meter high, and it casts an 80 centimeter shadow. So first of all, notice we have different units going on here. We're going to have to do something about that. And the cactus is casting a 15 meter shadow. They want you to find x. How tall is the cactus? So all we have to do is set up a proportion. This over this equals this over this. Cross multiply. Because these are similar triangles, because of the parallel lines here and the angles matching up, I can just set up a proportion, cross multiply, and solve. But I do need them in the same units. So centimeters, like a century is 100 centimeters, centi is 100. And so every meter is 100 centimeters. So I'm going to go ahead and change this one into centimeters. 1 meter is 100 centimeters. And then this one right here, 15 meters, you just times it by 100. It's 1,500 centimeters. Okay, so now everything's in centimeters. You can't do the cross multiplying unless everything is in the same units. So be careful with that. And now just match up your corresponding sides. So lots of ways to set these up. I'm going to do 100 over x. 100 over x equals, make sure that we use the centimeters, 80 over 1,500. Okay, and now we're just going to cross multiply like we've studied that we can do. So we're going to have 80x. 100 times anything just adds 2 zeros. So you're going to have 1,500 times 100 gets 2 more zeros. So that's 150,000. Then we're going to divide by 80. So divide by 80 on both sides. So we're going to do 150,000 divided by 80, that's 1875. Now that's in centimeters. So the cactus is 1,875 centimeters tall. That's mathematically correct. If we were giving the height, though, in a realistic manner, we're probably not going to do it in centimeters. We're probably going to put it back into meters. So just like we multiply by 100, it adds 2 decimals. If you divide by 100, it brings those decimals back. And so this is 18.75 meters. So either one would be acceptable for a math problem. But it is good to know how to go back and forth between those, nice and easy. All right, and then the last one, we haven't looked at a side angle side situation. We've just been looking at angle angle. And so let's talk about what's required here for a side angle side. So we have these two triangles. They may or may not be similar. We currently don't have enough information to say that they're similar. We have two sides, and we can't even say they're in proportion to other sides because there are no other sides. Like, you can match them up 15 over 12, but that's just going to give you a ratio of those sides. You would need all the sides or side angle side to make this similar. And I only have one pair of angles. I don't know anything about the other one. So I need more information to say that these are similar. So we're going to pick which piece of information is not sufficient to conclude that they are similar, meaning 3 of these are good. 3 of these create a situation where we do have similar triangles. So if I had one more pair of angles, like if I know that for instance, Q is equal to B, then I know P and A are the same. I know Q and B are the same. That's enough to say these are similar by angle angle. So that one's good. Same thing for R and C. If I knew R and C were congruent, I already know P and A are congruent. So that's enough to say by angle angle that these are similar. So A and B would both be correct answers, and we're looking for the one that's not. And so we have C and D, which are comparing sides. So first of all, it can't just be given measurements of sides. They have to be in proportion to each other, meaning their ratios match up. So first of all, let's go ahead and see what's the ratio of the two sides that were already given to us. 15 over 12. If you go ahead and you simplify that, is 5 over 4. So that's the ratio between those sides. Everything else that we look at here is going to have to be given to us in the same manner in terms of the ratio. And so if I compare 12 to 9.6, before I even worry about where they're at here, I might as well check and make sure they're in the same ratio, because if they're not, then it's not enough information to prove that they're similar. So we'll start here. 10 over 8 is 5 over 4. So that one would be good. And then this one right here, what happens when we do 12 over 9.6? Well, when you go ahead and you put a fraction into the calculator with the decimal in it, it's going to give you a decimal answer, which is fine. Now remember, you could go ahead and move the decimal to the right. You could do 120, move that decimal to the right, over 96. And notice that's 5 over 4. So you can always do that as a quick problem solve there. But we also saw that it was 1.25. So I've proven it's 5 over 4, but I've also seen it's 1.25. And if I couldn't remember how to get that fraction there, you could always go back and check these. 5 divided by 4 is 1.25. 5 divided by 4 is 1.25, or even 15 divided by 12 is 1.25, right? So these ratios are all equal. We would have two pairs of sides that have the same scale factor. They're in proportion. So I need to pick the one that creates a side angle side and not a side angle, because side angle is not enough to prove that two triangles are similar. And so we just kind of want to look at the sides they're giving us here. Let's start with this one. PQ would be this side right here. And here's the angle, and here's the other side I've got. So the angle would be between the two sides. AB over here. I would have this side proportional to this one, congruent angle, and then proportional sides here as well. So this one would be enough. This one's good, just like the angles were good. This one would be angle, 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 angle. This one would work for side angle side. And so obviously D here is the correct answer for the question, meaning it is not sufficient to prove that these are similar. And it's because we have QR and we have BC. And so if you ignore the blue ones for a second, pretend we don't have those. If we just have the red, the 15, and the angle, that's side angle. The angle is not between the two sides. Same thing here, side-side angle. Okay, so this is side-side angle, which is not good enough for proving things are similar. So the correct answer to the question would be D, and this is a good illustration of what you need for SAS.